Forget the buzzwords for a second. We're talking about precision, not just any precision, but high precision, real-time location tracking, and how it's changing the game. Specifically, let's dive into the world of domestic Bluetooth AOA+, where accuracy meets practical application. So, where does this tech shine? Think complex indoor spaces, lots of rooms, high ceilings. Places like prisons or large warehouses where traditional methods hit a wall. But it's not just confined indoors, it's designed to handle sprawling outdoor areas too, campuses, industrial parks, whatever size they come in. The key here is flexibility, adaptable precision, long-lasting tags, and the ability to integrate seamlessly with existing systems for security, service, or management. And, crucially, it aims for a low total cost of ownership. It's about being smart, not just expensive. Alright, let's talk market potential. Outside, GPS and Beidou are king. Inside? Well, iBeacon or RFID give you basic location, but what about true precision? That's where the action is. High-precision indoor positioning is the next frontier. Technologies like 2.4G AOA and UWB are stepping up. The problem? Existing solutions often lack the accuracy, speed, or capacity needed to unlock the full value of location data. We're on the cusp of an era where pinpoint accuracy indoors, combined with IoT, will spark entirely new applications across industries. The demand is there, the tech is evolving. Why Bluetooth AOA specifically? Because the IoT landscape is fragmented. No single silver bullet works everywhere. Bluetooth 5.1, launched in 2019, brought angle of arrival and angle of departure, a game-changer for precise positioning. Look at the numbers. Bluetooth positioning is growing faster than audio, data transfer, or even networking. A staggering 43% CAGR. Over 400 million chips expected for positioning in 2023. This isn't just hype, it's a massive, open ecosystem. We're not just selling tech, we're building partnerships. What makes Bluetooth AOA compelling? Mark Powell from the Bluetooth SIG puts it bluntly, positioning services are one of the fastest-growing solution areas. Billions of products annually. Why? Because precise location and direction data unlock AR experiences, indoor navigation, object tracking. As Sun Xiao from the Bluetooth SIG noted at IAIoT Shenzhen, the future 20 years will be driven by low-energy Bluetooth. The mantra? Openness. Open standards, open innovation, open collaboration. Join the party. Now, who's actually delivering this high-precision 2.4G AOA? It's tough. Overcoming antenna design, algorithms, and terminal compatibility is no small feat. Currently, you've got Quappa from Finland and CoreLink from China leading the pack with scalable, compliant products. While others are emerging, CoreLink focuses on a fully independent, controllable solution. We're not just providing hardware, we're offering a complete package, tailored solutions, system integration, custom development, fusion with AI cloud, and rapid support. It's about making that precise location data valuable for your business. Let's put bleaoa against the heavyweight contender, UWB. Check the specs. bleaoa uses standard Bluetooth 5.1 base stations and tags, BT 4.2+. Typical accuracy? 0.3 to 0.5 meters. Refresh rate? High. Compatibility? Massive. Tag power consumption? Low. Base station cost? Moderate. Tag cost? Very low. Plus, it supports downstream broadcast and IoT gateway capabilities, UWB. Higher accuracy, 0.1 to 0.3 meters, but look at the trade-offs: medium refresh rate, special UWB tags only, higher power consumption, significantly higher base station and tag costs, and no downstream broadcast or IoT gateway support. Different beasts, different fights. Okay, let's break down the BLE advantages because sometimes vendors can exaggerate. First, accuracy, 0.3 to 0.5 meters, comparable to UWB. Second, concurrency. Single base station handles 500 tags per second upstream, unlimited downstream. Third, power. BLE tags last over 5 years. Fourth, cost. System cost is way lower than UWB, tags can be super cheap. Fifth, size, tiny, diverse forms. Sixth, ecosystem, billions of compatible devices, including phones. So, yes, BLE is genuinely strong in these areas. Don't just take my word for it, see the data. Comparing Core Location's 2.4G tech to UWB head-to-head? Let's get specific. 1. Highest accuracy at the same deployment density, under 30 centimeters. 2. Lowest power consumption, our tags run on a button cell for over a year, UWB tags typically last weeks to months. 3. The only way to achieve two-dimensional positioning with a single base station. 4. the only option for centimeter-level positioning on ordinary smartphones. Most phones don't support UWB. Now, comparisons must be fair, same conditions, otherwise, it's just Lumang. But the facts speak for themselves. Reiterating the core strength of 2.4 GRF for indoor positioning. Fragmentation is key, no single tech dominates. Bluetooth 5.1's AOA/AOD feature is the catalyst. And the growth is undeniable, 43% CAGR for positioning applications, hitting over 400 million chips in 2023. This isn't just about the radio frequency, it's about the complete ecosystem, the wristband advantage, the sheer scale of adoption. How does this magic work? Bluetooth Angle of Arrival, or AOA, uses an array antenna and sophisticated algorithms to determine the direction of a Bluetooth signal. This allows for high-precision indoor location using existing Bluetooth devices and smartphones. Crucially, it enables single base station 2D positioning. Install one base station, get a 2D plane map. Perfect for those multi-room, high-ceiling environments where deploying multiple anchors is impractical or costly. It's elegant, efficient, and powerful. This is the domestic first mass production 2.4 GAOA precision positioning system. Look at the architecture. It's a complete package: positioning base stations, positioning beacons, the algorithm engine, configuration software, positioning interface services, and overall system services. Everything is engineered to save you every penny. The workflow is clear. Configure via CCS, upgrade locally, base station sends data to the algorithm engine, which processes it and sends it to the interface service. Our ecosystem partners play a vital role, interacting via the reverse channel. It's a holistic solution. Let's zoom in on the CoreLink Precision Positioning System's AOA base station. The antenna is a self-developed, low-profile array, fully forward-facing. This opens up possibilities for different shapes, strip form, large arrays. The motherboard framework is an edge node design, differentiated from the norm. This allows for more flexibility, PoE daisy, chaining for easy installation, potential for explosion, proof versions, and custom wireless backhaul options. It's built for adaptability and robustness. Here are the guts of our domestic, forward-facing, self-developed antenna and motherboard. We're not shy about showing them. Why? Because we stand by our claim of being domestically developed and self-reliant. We welcome scrutiny, disassembly, inspection. If you want to go far, you have to stand tall. Transparency builds trust. These are the components powering the precision. The soul of the positioning effect. The high-performance positioning engine. This engine is versatile. It supports multiple architectures like x86 and ARM, even running on small devices like Raspberry Pi. It's cross-platform, Windows, Linux, Mac, and importantly, supports domestic operating systems like Kylin. It's designed for cloud edge fusion, supporting both local and cloud deployments. It's the brain that turns raw signals into actionable location data. Diving deeper into the CoreLink Precision Positioning System's positioning engine and system. The algorithm is fully self-developed in C/C++, optimized for edge computing, multi-threading, and domestic, controllable CPUs. Cross-platform design covers Windows, Linux, Mac, and domestic OSs like Kylin. Note the validation: tested and verified on OpenNoiler, Kylin Server, and Kylin Sec Server, including Selinux. We're serious about compatibility and security. Terminal support is broad. Our system works with mainstream 2.4 GRF chips, including TI, Nordic, Dialog, and domestic alternatives. It supports various wearables like beacons, wristbands, and handbands. Mobile devices like Android and iOS phones, and even law enforcement recorders are supported. We even support WeChat mini programs. Security is paramount, utilizing both ISM and non-ISM frequency bands, 2401/2481 MHz and 2380 to 2500 MHz. This ensures robust connectivity and flexibility. Information security is critical. We use private frequency bands, primarily ISM at 2401 and 2481 MHz, and non-ISM bands. Network isolation is achieved through VLAN segmentation and single-direction RS-485 communication. This architecture ensures that the positioning network is secure and isolated from other potential threats. Data integrity and confidentiality are non-negotiable. See the effect on mobile terminals? Apps and mini programs. Imagine a user holding a smartphone, looking at a building layout on their screen. The app accurately shows their position relative to the room layout, pinpointing beacons placed within the space. Below, you see the actual location points on the map matching the real-world positions. This is the tangible result of high-precision indoor positioning, delivered directly to the user's pocket. Anti-interference technology is crucial in crowded RF environments. Our core location system operates in the 2.4 GHz band. To combat interference from other Bluetooth Wi-Fi systems, we employ channel selection techniques. The chart shows the crowded landscape of 2.4 GHz, with blue dots for BLE, purple circles for Wi-Fi, and green areas indicating our core location channels. Our system effectively navigates this interference, ensuring reliable performance even in complex industrial settings. Reverse channel technology adds another layer of capability. Our system allows the base station to control the beacon via a reverse channel. For example, if a worker enters a restricted zone, the system sends an alert through the reverse channel to the worker's beacon, triggering a vibration alarm. This enables real-time, two-way communication and immediate feedback based on location events. System integration is seamless. Core Location uses a B/S web architecture for quick deployment and browser access. We provide rich APIs for data integration. Need real-time location, historical trajectories, event notifications, big data analytics and reports? We've got you covered. This allows easy connection to various existing systems and applications, maximizing the value derived from the location data. Planning and simulation are key. For accurate Bluetooth AOA simulation, you need 4 things: CAD drawings, installation height, site photos, and precision requirements. Missing any is like talking results without conditions. We help partners iterate their AOA capabilities. Coverage radius R is roughly 1.5 times the height H. Multiple base stations create synergistic coverage, 1 + 1 greater than 2. The simulation tool visualizes this, showing signal strength across different zones. Installation and deployment are straightforward. Base stations are typically mounted horizontally on the ceiling using PoE cables for power and data. PoE daisy chaining simplifies wiring. However, proper placement matters. Avoid non-horizontal mounting, corner installations, and obstructions like metal grids or beams. Keep the antenna clear of interference. In small rooms, center placement is better. For large-scale deployments, aim for horizontal mounting, ideally aligned with cardinal directions, north, south, east, west, for optimal calibration and performance. Finally, the deployment network topology. Servers and positioning software process the data. PoE switches power the base stations and connect them to the network. Base stations communicate with beacons via Bluetooth. The table summarizes the components: display devices, positioning devices, base stations, tags, network equipment, switches, cables, servers, and the core software systems, core location engine, business platform. It's a well-defined, scalable architecture designed for reliable, high-precision location services.